Hi, I'm Dr. Shao, and here's my office in Huntington Beach, California. So I've been 3D printing in my dental clinics over the last 6 years or so. So I started about 2017. The first 3D printer that I got was actually a dental 3D printer. And currently I own more than a dozen 3D printers, and that number seems to creep up every couple of months. Today we're here to talk about dental 3D printing with HeyGears, and we have our guest Dr. Andrew Ip here, and I feel like we're similar-minded people, so hopefully we're going to have a good chat.
Yep, and I'm Dr. Andrew Ip. I'm from Sydney, Australia, so a long way from home, and I'm here in Huntington Beach. Lovely place, fantastic. I run courses in Sydney, Australia and other parts of Australia as well on 3D printing. I teach a lot of dentists and technicians how to 3D print and introduce it into their practices. And basically anything that you can 3D print in dentistry, I've probably done it at least once before. So I've operated about 19 dental 3D printers in total so far, and that's almost definitely going to increase. So I like to think that I know a bit about these machines and how they work, what's good, what's not so good. So yeah, we're going to have a bit of fun today. We're going to talk about hardware, software, 3D printing, and how it can help in any dental office.
I think part of it is what drives the 3D printing revolution in dentistry and digital revolution. The technology was always there, but today with AI, with a lot of software, design services, and also Chairside design softwares, it makes things so much easier that I think most people and most dentists will be able to access this technology Chairside.
You raise a really good point, because at the end of the day, 3D printing is a tool, and the limit really is your imagination. Yes, you can print crowns, you can print dentures, you can print surgical guides, you can print trays. You're just limited by what you can think, really.
Yeah, I share that view with you as well. A lot of people think, hey, I want to go out there and buy a 3D printer, so what can you do? I always tell them, it can do everything. But what makes sense for you to make, and what makes sense for you to send it out or use a different technology. Now, similar to you, I have CNC in the office. We have different type of printer. We have all kinds of different fabrication methodology. We have access to the laser cutter as well. 3D printers can do almost everything, but the way that I describe it is I always tell people it's similar to walking into the kitchen. And when microwave was first invented, people tried to make it out to be some magical device that now you can replace every single appliance in your kitchen with a microwave. You can bake a turkey with microwave, you can boil water with microwave, you can bake bread with microwave. You can, but at the end of the day, it's part of an entire ecosystem. Microwave will do something better than any other appliance in your kitchen, but by the same token, if you try to make a burger, if you try to cook a steak, you still want to use a grill. And there's a place and time for all the different type of technology. So I feel like once the dust settles, 3D printer will be a big part of the dental production ecosystem, but it's not going to replace everything else. Because in my office, the thing that I can 3D print, I can't think of a better way to fabricate the prosthesis or to progress to an efficient workflow without the 3D printer. So in my office currently, we operate a fleet of 5 printers full times. So on a regular basis, these printers will be utilized on a daily operation. The number one thing that we print in our office is orthodontic aligners and wax up models. We also do a lot of orthodontic splints, so all the splints are printed in-house. All the orthodontic aligners have been done in-house in the last 5-6 years. For every single surgical cases with regard to the dental implant, we print surgical guide for everything. For every single cosmetic case, we print a wax up and a shell tent for all of our patients. And these days we're diving into removable, so that's why we have the HeyGears Chairside Pro here. We've been very happy with it, and the design services with regard to full denture, partial denture, even Nesbit design. So whatever is that we can apply the technology to, we try to. Sometimes it works, sometimes it doesn't. But today in 2023, I believe a lot of these technologies is very mature. I can foresee in the near future, most dental offices should have intraoral scanner. They should have a Chairside 3D print and 3D printing ecosystem and CAD design software. The price have come down to a point where it's accessible by nearly every office.
And then even you mentioned CAD design as well. Sometimes when you get into new technology, it can be quite daunting, whether it's CNC milling, whether it's 3D printing. So when you add onto that, learning basic CAD, some people learn it very fast, but other people take a little bit more time. I like to think that I'm pretty tech savvy, but even then I don't want to spend my whole weekend designing lots of things. I'll source that components to HeyGears when I need to. Very quick turnover, I think within 12 to 24 hours most of the time. I'm quite happy with using a design service. And so I use a HeyGears design service, which is fantastic. It's incorporated with the 3D printing system that they offer as well, but I mean, it's open to anyone really. So that's one thing to also consider when anyone kind of gets into 3D printing, is that, suddenly, you don't want to be put in a situation where you're learning 3D printing, then you're learning CAD. Sometimes it's just easy to focus on the 3D printing side of things. Outsource the design for the time being to a company like HeyGears. And then once you become a bit more familiar with 3D printing, your printing's a bit more consistent, then you can start learning a bit more on CAD.
So I think what you're saying is true. It's like a lot of people come up to me and they say, well, I'm interested in 3D printing, I'm interested in technology, but I want to wait until the technology is mature. So the way I'll describe it is this. A 3D printer and the material, they're tools. Your know-how, fundamentally what you're trying to acquire isn't a piece of equipment. What you're trying to acquire is a mindset of problem solving. So get into CAD design, get into 3D printing right now. You can do something easy. And today is so simple.
So simple.
You don't even need to go out there to learn how to design anything. You can submit things to online design services like HeyGears, and then design services will give it to you the very next day. The ecosystem is so simple to use. The failure rate is so low these days. Get into it. Learn the workflow, learn the mindset.
Yeah.
So the more you know about the technology, the faster you run. So the gap between people that already know about 3D printing and the people that haven't started yet is gonna widen over time, not narrow. The best time to get into 3D printing was yesterday.
Yeah, absolutely.
But today is not too late. And then by tomorrow, you're gonna be further behind than everyone else. For most dental clinics, I don't think it's feasible to have a $200,000 CNC mill system. But a $15,000, $20,000 3D printing ecosystem, everybody can afford that.
Yeah.
So we're discussing software and basically the efficacy of using the system. And I think one of the big things over the years as 3D printing technology started to mature, our application, the capability of the 3D printer started to expand based on the number of resins that's available.
Yeah, and now there's so many resins available. Of course, we've got a whole list of samples right here. I've been using the surgical guide resin from HeyGears with a lot of success. I like the clarity, I like how it prints out, and it prints out perfectly on the chairside unit used in the mouth. It's really, really quite nice. Some other surgical guide resins out there, they tend to crack. I basically use plan and make a surgical guide for more or less all my implant cases.
I do the same, yeah.
I think from a regulatory point of view, it just shows that you've put in effort and you've done the study to really, plan and place the implants in the right place. So yeah, I plan all my cases routinely now. I very, very seldom do implants free-handed. I'm a big fan of their temporary crown and bridge material as well. I think it polishes it up nice, and that's really important for me because when we talk about resins in direct contact with mucosa or soft tissue, we want it to have a really, really nice surface. And we want it to be fully cured as well, because otherwise you'll get a bad soft tissue reaction. So with my immediate implants, I basically plan a temporary prosthesis, which is printed out of their temporary crown and bridge material. Whole range of shades. I've never had an issue with the shade selection. And really, I don't have experienced any negative events with the soft tissue. So yeah, really enjoying their crown and bridge material.
So speaking on the surgical guy, one of the things I always talk about when I go out there and do presentations is whenever I sit down with a patient, I tell them, hey, we're going to take a CT scan. We're going to show you how to design your surgical guide, exactly where your dental implant is going to be, the proximity to the nerve of the sinus. And we're going to use our fancy 3D printer to print you a surgical guide, and we'll place this dental implant. You'll be way safer. You'll be way faster. We expect better healing. We expect a much easier way to restore the tooth's proper contour.
Yep.
My patients always look me in the eye and say, hey, so you tell me about all this fancy technology, all this fancy equipment, so how much is it gonna cost me to get this surgical guy done? And this might be controversial, but I don't charge for surgical guys, right? And then when the patient asks me about why, and I tell them because principally surgery are expensive because of the risk that's inherently involved. So when I'm telling you about this technology, the reason why I love it, from a patient perspective, you might not know the difference between how we place a dental implant, but from a surgeon perspective, I can tell you it feels so much safer. It feels so much more secure. I'm reducing the risk of surgery by such a huge margin. That huge margin of safety is my profit. So I don't need to charge you a dime for it. And in fact, if I tell the patient that I will charge you $200, for example, for a surgical guy, and the patient refuses, now I'm in trouble. Because now I have to place this implant without a surgical guy, and it makes me sweat just a little bit more. So I'd rather just do it for them for free. So there's no possibility.
And I don't charge for it either. Basically, I factor it into the total cost.
Right? And is that a really interesting concept? Those are the type of mindset that we didn't set out 3D printing to understand in this. Once we started doing it, it becomes...
It just became second nature.
Right? You kind of snap your finger and you just go, I would not place an implant without a surgical guy. You basically have to pay me more to do it without a surgical guy than to do it with a surgical guy. I anticipate the day when most people kind of realize that. And I think things like surgical guy, things like 3D scanning, cone beam CBCT, and 3D printing. I'm an 80s kid, so I feel like I'm one of the very last generation of dentists that kind of grew up in an era, that was educated in an era that was prior to digital. So in dental school, they didn't tell to us about CBCT. There was no talk about, you know, CAD/CAM, CEREC, and obviously not 3D printing. But so I lecture at UCLA as a guest lecturer on 3D printing now. So I feel most dental schools from this moment on, 3D printing will be incorporated into their curriculum, and when they graduate, they will already know the capability and the feasibility of utilizing this technology. I think dentistry will change after that, and it'll change a lot more rapidly than what most people realize.
It is really changing. When we talk about printed onlays, inlays, crowns, veneers, you know, they're not currently as strong as our traditionally milled materials. That being said, there are advantages to printed restorations. Number one, speed. You can print a whole lot of things in one go at the same time, and its material cost is really quite negligible compared to some of these milled materials. They look nice. Another advantage is that, especially for patients who are expecting to replace these in the future, you can repair these, right? You can, you know, roughen the surface up a little bit if they happen to break, apply your composite bonding system and repair it with just traditional composites. And then you've increased the lifespan of this particular restoration for a bit longer. Right? Very cost effective, because not everyone will be able to pay for or want to pay for a traditionally, you know, milled ceramic, crown, veneer, all of that stuff. Not every case should be done with a printed restoration, in my opinion, but there are certain situations where it's perfectly valid, and honestly, you'd be really surprised how long they last. And yeah, they're really case selective, that being said, but yeah, they work very, very well. They do have a place in the market.
My take on that is might be a little bit different. When I was talking about ceramic, definitive ceramic restoration, and someone walked out to me and told me, see, you keep comparing chairside mills to chairside 3D printing material. So we're comparing things like zirconia and Emax to 3D printed resin. Basically, they are ceramic infused composite material.
Absolutely.
And for cases like that, and this is an old prosthodontist, I believe he retired, but you know, he's in his 60s and 70s, and he asked me, what is the ideal restoration benchmark that we should aim for? Now, most people that talk about dental 3D printing, they'll always quote, well, Emax is this strong. And then zirconia has a, 700 to 1,000 megapascal. And then whereas your 3D printed restoration is only about 150 currently, and then maybe you'll go out to close to 200, but we're still nowhere close to Emax, which is about 500, or zirconia, which is close to 900. But this prosthodontist told me, what is the best material? What is the gold standard in dentistry in terms of restorative material? It's not zirconia, it's never been zirconia. No. Increasing the flexural strength has never been the goal of dental restoration. The ideal material was actually gold. But the problem is that it doesn't look good, it doesn't bond to resin. So the goal for printed restoration shouldn't be how do we match Emax? How do we 3D print Emax? How do we 3D print zirconia? The goal should have always been how do we engineer, how do we fabricate a material that is the ideal material for the human dentition. And in that, I believe the goal that we're trying to achieve is something that has the mechanical property of gold, that is not completely radio opaque, that is bondable, and that is highly aesthetic. I believe in that end, given the slope in which 3D printing technology and resin chemistry is improving, 3D printing technology will get us there much faster than mill technology. So I feel like today, as it is right now, there's certain usage for chairside printed direct restoration material. It's already far superior to what we had even a year ago, even 2 years ago.
I also agree that I think a lot of companies, a lot of dentists, we get stuck on what we're comfortable with. Okay, so Emax has been in the market so long. Zirconia has been in the market for so long. So we just can't keep focusing on it. Everything has to be compared to that, right? But why? Why should we develop something to copy that?
That's right.
We already have Emax and zirconia. Why do we have to make something like that? Right. We should be changing our philosophy a little bit, okay, and looking at, okay, what are some of the disadvantages of ceramics, brittle products? Maybe sometimes having a bit more give is advantageous in certain situations, right? So I don't think we should be so stubborn and just completely focus on certain milled materials. We have an opportunity here to develop something of its own.
Right. I was always pretty insistent that we should never have a material that is harder than your natural dentition to a certain degree that if the patient accidentally clinch on something hard, the zirconia crown will be perfect, but the opposing dentition will crack in half. That's not what we want. We want the restoration to actually shear off and break off before the natural dentition gets hurt. I think from a patient care perspective, that's what we should be aiming for. And the other thing to add to the restorative solution is two aspects. We continue to kind of benchmark, even for you and I think we go like, well, we're doing a posterior crown today. Are we going to do an Emax? Are we going to do a 3D printed crown? Here and there, and those are very valid questions. But I believe currently less than 15% of clinics in America actually have a chairside CNC mill because of the cost. A brand new CEREC system costs upwards to over $200,000, and not too many offices can afford that. So for the most part, even in America, most clinical cases are sent out. But there are huge advantages of being able to fabricate a restoration chairside. It's very difficult to temporize partial restoration, and then whenever you need to bring the patient back to replace the temporary, will increase the chance of postoperative sensitivity, possibly leading to secondary decay, possibly leading to root canal that otherwise could have been avoided. You can't place same-day restoration unless either you have a chairside mill, which is close to 200 grand, or today you have the option of getting a chairside 3D printing system, which costs about 1 order of magnitude less. So even with the scanner, the design software, whatnot, it costs way less. We're talking about 10% the cost of the chairside mill system. And I think for offices that haven't been milling chairside, or for offices that haven't used CEREC, a lot of the advantage of the 3D printing is lost on them. So why should I do this chairside when I can just send out to a laboratory, have a laboratory fabricate the crown? Even for cases like this was a partial denture. Imagine if you can deliver partial dentures. This is a real world case, and in this particular case, we had an emergency of a patient coming in with broken anterior teeth. She had a family event to go to. She didn't want to go without a tooth. This case was delivered the next day. So in this particular case, we scan the patient's dentition. Because we're busy that day, we send the case out to HeyGears Design. And then surprisingly to me, they returned the case in under 18 hours. And we're able to print it the very next day on the printer right over here. And then it fits almost perfectly. Being a chairside and being able to look at the design, modify the design ourselves, print it ourselves, I feel like at the end of the day, we offer the patient an option that's much higher quality and is way more efficient. what we're really pushing now in this office is that we're saying, hey, it's really exciting to be able to deliver next day restoration. Now it's possible to do it the same day. And I was told that HeyGear even has a 2-hour service for the design. So when you have your emergency, now we're trying to deliver something like this to our patient the same day. And to me, that is amazing. You can put a dollar value on that, and even to be able to do a couple of cases like that clinically, I think it really changed the mindset of clinician like myself. Yeah. And once I deliver that, and this is a replicated one, so the real one is already in my patient's mouth, that patient is never going to go anywhere else. The next time they walk into the dental office and they need to have a crown, they know they need to have a partial denture, a denture, or a split, they expect it the same day or the next day. We spoil them with the efficiency of the new technology. Yeah. They're your patient for life. Yeah. And from a business owner perspective, that's exactly what I'm observing. And we didn't set out to do things this way. This is not why I bought a 3D printer, but these are all the hidden benefit that is not immediate apparent for people that haven't gotten into the art yet. Speaking about the dentures, one of the things that really left an impression on me is that when I got the Chairside Pro system, the first thing that we did was I used it to print some removable cases. Yep. So full complete dentures and partial dentures. We've been using a lot of different resins. So prior to this, they're very brittle, they're very weak. So we'll deliver something and the patient's extremely happy. They'll come back a week and a half, 2 weeks later in pieces. Now the HeyGears denture resin, the denture base and the denture teeth resin, in my opinion, is probably one of the best looking on the market right now. Yeah. I don't know, we can probably do a close-up on this later on, but when you look at this denture base and the denture teeth, I think one of the impression that I got from it is, online, you see a lot of KOL, you see a lot of educator, and they spend a lot of time and energy, and they sit there and paint and stain their denture teeth and the denture base. Yeah. I'll say that clinically, I've very rarely ever done that. And it's because in a busy clinical setting, to me at least, it's not really realistic. Like once you print something and you go out there and try to make a photorealistic denture, if my patients are paying me 5 times as much for the denture, then yeah, I'll go in there and do that. And if you tell them like, hey, my denture fee is this high because it takes me all this time to stain and glaze it, probably going to go somewhere else. Yeah. The thing with the HeyGear denture base and also their denture teeth, I'm not sure how they formulate it, but it's a very, very good looking resin. I actually use some of the denture teeth resin to print toys for my kids because they look gorgeous. The way that the light passes through the light, it makes it look multi-chromatic. So this is one of the few resin on the market I feel like you can print the teeth and the denture separately, combine them together, glaze over it, cure it. And
it looks decent.
And it looks better than what most laboratory can fabricate it. The teeth look multi-chromatic. You can see the translucency on the incisal edge. Yeah. You can see the dentinal shade at the body and to the cervical side. So the way that we would actually bond this, and my recommendation is that when you bond the denture teeth and the denture base together, use a slightly darker denture base resin, and you'll add depth to the coloration where the sulcus is. And once you cure everything over, when you take a photograph, it's hard to imagine that this has no staining and glazing on it, and all the staining and all the different hue and the shade and the value are in the right places. For me, I find that a little bit shocking. So we have used these for immediate provisional on the anterior cases, and they just look gorgeous without any staining and glazing. Also, the denture teeth comes with a variety of different colors. I'm using A2 right now because I feel like my other resins in other ecosystems, they're always B1 or they're very opaque and very white, and they require staining to get them to look right. But with this particular resin, I feel like they're fine. You deliver it and the patients never complain about it because frankly, they look better than their previous set of denture and their previous set of resin.
And you raise a good point. I mean, it does come in a whole range of colors, and it's actually one of the resins out there that I feel is actually quite predictable when you print it.
Yeah.
That you get the cut. If you want A2, you will get A2, right? More or less.
Right.
Whereas there are other resins out there in the market where it's marketed as a B1 material. You print it and wash it and cure it, and it's grey as heck. So that's not really something that we want. Predictability at the end of the day.
Yeah.
We want it. We want to print it once, and when we want to print it, we want it to work.
That's right.
You don't want to spend all of this effort and then find out, put it in the mouth, and it's the wrong color. Worst feeling in the world.
I feel like the next generation, the high impact denture that's coming out from various different companies, including HeyGear, I think that's going to be a game changer because based on the preliminary study that's being released, that material is going to be stronger than PMMA. It would actually be ideal to do it in-house. And the question that people have in well, how do you design it? What software do I need? Do I need to spend $8,000 on an ExoCAD or 3Shape design software? It's like, no, you send it to the HeyGears Design Services. They charge a very low nominal fee, and then they will have a turnaround much faster than you think. And that's been my experience. And like you're saying, the dependability of an ecosystem and the workflow is critically important, it's paramount. I can't bring a patient in and say, hey, I'm gonna deliver a same-day partial denture or a next-day partial denture for you, and then there's a high probability that you're gonna get a print failure. You know, in some of the consumer level printers, this might not be an issue if you're not doing it chairside. So if you have a patient that needs a denture in 2 weeks, and you can fiddle around your third-party printers, you know, you can calibrate your different resin, that's fine. But when you have a patient in the chair, I need to get this shell temp veneer printed right now, chairside, right after I prep it and temp it. You need to have a highly dependable ecosystem. And to me, because I always compare the cost of 3D printing system to other systems in the dental clinic. So for example, X-ray sensor is $8,000. A CBCT used to be 50 grand. My CEREC milling unit was $70,000. So why are people complaining about the cost of 3D printers and also 3D printed resin compared to what? Why am I trying to save a few $1,000s on the printer, on the most critical component for chairside productivity? To get something that is unreliable, and now I don't know whether or not I can deliver. Now, every time I go into the patient and go, all right, we're gonna do a surgical guide this afternoon, the patient is gonna come in 10, fingers crossed, I hope the printer is gonna work today, it's not gonna be temperamental, I'm not gonna get a failed print. And that's no way to operate in a chairside environment, in my opinion.
It's great when it works, but when it isn't, that's when you get, you're put in a very high pressure situation. The great thing about doing everything in-house is the fact that you can quality control. So consistency is really important when it comes to any ecosystem, because you really just, especially for when we're working on patients, we just want things to just click and work, and you don't want something to fail or you get a misfit or some sort of issue happens right when the patient is in front of you. It's a very stressful situation to be in. No one wants to be in it, and you can get, of course, cheaper or more affordable printer systems out there, and they may work, they probably will work if you put a lot of time into making them work, right? But I think our patients deserve a little bit more than that. They are expecting consistency and reliability from us as clinicians.
I think it's important to point out that we're not saying just buy expensive printer and they'll be reliable, because traditionally we have tested enough printers to know this, right? Just because you pay a lot of money for ecosystem doesn't make it better. There's some extremely expensive printer, they're completely unreliable, completely unusable clinical side. There are printers that have poor engineering that makes them not feasible to place next to the patient chair. My printers are all in my office, it's next to the patient chair, it's in the operatories. But case in point, I feel like after I work with many different companies and study different type of printers, I will add to the point that dependability, quality, and reliability doesn't come by accident. It's not a game of probability where if I make enough product, then one of them is going to be real good. In the DNA of the company that makes products that work really, really well. So in this case, I'll say HeyGears is a great company. These companies that do great things, that are very innovative and they have very dependable product, you see it in their DNA from top to bottom, from CEO down to the customer service, down to the engineer. And you can tell this when a company made their own machines, they write their own software, they have their own curing system, they make their own resin, they have their own workflow, they have their own design services, they make their own slicers. Everything is vertically integrated. It shows that they're not taking any shortcuts. This is not a company that go out there and source some parts, they put together a machine, they get someone else to build this, they use a resin from another party, they buy a post-cure from another party. Now when something goes wrong, similar to what we're talking about in efficiency and they're taking the responsibility, is that if you can point your finger at someone else when something doesn't work, at the end of the day, it doesn't help the customer, it doesn't help your patient, but also it doesn't help you learn how to improve, because now the mistake is not my responsibility, so I can improve it. So HeyGears have their own printer, they have their own ecosystem, they write their own software, they make their own resins. And one of the things I really like about HeyGear is that their ecosystem is built upon laboratory experience, and they have hundreds, if not thousands, of printers out there in the wild, and they're doing probably millions of cases on a weekly basis. So when they tell you that this material works, when they tell you that this design services works, they have a wealth of data to back that up. And I find that to be very refreshing. And from a clinician point of view, it gives me a sense that, oh, this is dependable and this is safe, because so many people have used it and they know this material very, very well. So when they design their software for slicing, for printing, the print success is really high. Because any mistake within the code, any mistake, any inaccuracy within the printer, they're going to see hundreds, if not thousands, of failures on a daily basis. So by narrowing down all that, by feeding through the data and the utility they have across the board, they manage to make a very, very reliable system. And I really respect that about that.
Yeah, and they really have, I guess, taken all steps considered. Right?
Yes.
So, and I guess that's their approach. That is, yeah, they make lovely printers. They have a design service as well. But they're really kind of like, in their cloud-based portal, really just factoring all of that together. So everything is in the one place. It's easy to follow, step by step, and it's just making it easier for the practitioner or the auxiliary staff. They've really just taken everything into consideration, rather than, okay, I'm just a printer company, I'm just going to make printers and that's what I'm going to do. Anything happens, that's your problem.
That's right. That's right. I think it shows how serious you are about the service of the product that you do. The same thing as a dentist when we see a patient, right? If I take responsibility from beginning to the end, I will give you a warranty on the product that I do. It shows a sense of chain of command and responsibility. But in my experience, in my observation, in the dental industry and in the industries in general, very few companies do that. But you always know which company do it, because the companies on top are the one that do this. So they will take no shortcuts.
You have the Chairside Pro unit right here.
Yes.
How have you, I know you've only got it recently, how have you kind of, what's your experience with it so far? So
my experience was the Chairside Pro. I have so many printers in the office, so when I evaluated it, I was trying to benchmark them against each other. So I really find a printer that I find very impressive in one or another, but the Chairside Pro has been great for me. I think they strike the perfect balance in the print surface area and also the resolution. So the Chairside Pro here has a 1080p projector with a very good anti-alias algorithm. It's set to 75 micron native XY, which is really good. I think it's at a level when you print direct restorations, even without any post-processing, without any polishing, you don't really see the layer line that much. That also has to do with the resin formulation, but because HeyGear makes their own denture teeth and also their own denture-based resin, you don't have to do too much polishing. I print with the denture teeth resin a lot to use for denture teeth and also for chairside mock-up. I love to use it for veneer show temp because it's so pretty. We don't need to polish the surface of it. It's highly aesthetic, and so far for me, the denture teeth resin, the success rate has been 100%. In terms of, I haven't had one single failure on that.
And I have the chairside unit, and basically almost 100%. Very predictable, and it's super easy. Out of all the printers that I have displayed in my clinic, that chairside unit has got the most praise, for sure. It looks nice. It's meant to be presented.
Yeah, the design for the unit, the little LED at the bottom, the big screen, I really like it.
And it's just I like it when companies put small little details into their products that don't necessarily matter, but it just shows a level of attention and care. Like when you boot it up, you have a really nice animation. The user interface is very easy to follow, right? It's just, these things are not necessary, right? But I think having finer details like that shows that you have pride in your own work, you have pride in what you do. So, and that clearly is reflected in the resins that they produce and the quality of prints that we get from the chairside unit. So I like the chairside unit. Certainly it's for more, I guess, smaller volume type of production. But for surgical guides, splints, restorations, it's not a problem. And of course, we can't forget about the whole ecosystem. I mean, we have to also consider the other factors at play: the wash unit and the curing unit. And the air wash, in my opinion, it's more specific for the chairside unit. I'd like to say I think it's actually the best wash unit in the market. You waste very little alcohol because most of the cleaning is with a centrifugal force. I think it's a very, very efficient way of cleaning any print without wasting a lot of alcohol. Very easy to use. You basically slot in the build plate as it is into the wash unit, and away it goes. And come back, 5 minutes later, and then peel off your prints and into the air cure, which is also another fantastic unit, which I really like as well.
Yeah, I'll agree with you. I'm a big design buff, so I like nicely designed things. In terms of 3D printing and the hardware in particular, you can tell which company take the time to actually design their product and make them look nice. And those companies I appreciate. I appreciate the finer things. The same thing as I love car design, so I like the cars that look nice, have a little detail to it. And I think of the Chairside systems that I have today, they have that in common. If the printer, if it doesn't look good, it's not going to be in my office because it's a reflection of what I appreciate.
Sure.
And we run a fee-for-service office, and we run a cosmetic practice and all that. So I want things to look nice.
Yeah.
So, like you said, the Chairside looks great. The Chairside Pro has a distinct design to it. Someone put their heart and their soul into making it look nice.
Yeah.
I think that's great. I have had printers in my office that look good on picture, and when I receive them, is this big hunk of metal with wire hanging out everywhere.
Yeah.
Stuff like that drives me crazy. And when I gave the feedback to the unnamed company, then they get really offended and go, "What do you care? It works." And it's like, no, that's not the point.
Yeah.
I know it works, but this type of aesthetic should not have been acceptable to you. That shows your company is not very detail oriented, or you just treat this like a mechanical device rather than a part of the dental clinic. And that goes beyond just the quality, the efficiency of the workflow, and the reliability.
Yeah.
It does reflect back on you. And that's one thing that I really appreciate about the HeyGears system. And also, besides design, I'm a technology buff. So I love things that are innovative, especially things that work. So with the HeyGears system, the air cure was very impressive to me. The first time I saw it, I just thought, oh, well, it's just a little jar of water, you cure it in there, you get rid of sticky.
It's so simple.
It's so simple. It's so simple that you think, oh, it's not a big deal.
Yeah.
But as soon as you start using it, you go, wow, this is actually really smart.
Yeah.
So with the denture base and also the denture teeth, we have glycerin in there. When we do the glycerin curing, the end result is phenomenal.
Yeah.
I think the glycerin submergence curing does a lot more than what we commonly think. So I noticed, obviously, you get a really nice and shiny surface, so you don't have to do any post-polishing, and that shine will actually last longer than polish. You also get the lack of distortion. So this is something that I found that's very interesting. So we've been printing shell temps.
Yeah.
And with anything that you print on a resin base that is very, very thin with different geometry, when you cure it, it's gonna warp. Right? So if you try to print something that is very long and very thin and you put it into most curing unit, you're gonna notice a little bit of distortion. I don't notice that with this ecosystem. I don't notice that with the air cure. And we're theorizing is because the glycerin and the rotating platform in there evenly distribute the UV radiation that's shining on top of the surface area of the print, but also it's dispersing the heat that's generated during polymerization shrinkage. Most resin have a specific gravity or density around 1.2 gram per cubic centimeter. Incidentally, glycerin has very similar density, which means when you put a print in there, it's actually suspended.
Suspended, yes.
Right. So with other resins of a company that I no longer work with, they would come out with a denture base or denture teeth resin that would actually start to melt and deform under the curing heat. So I don't think this happens with this particular resin, but the glycerin cure I think will prevent any drooping that's caused by heat. And that was something that I didn't anticipate. So I started to do a lot of benchmark testing. I noticed the geometric accuracy, even when you print something very thin, is highly accurate with the system. And that's one of the reasons for shell temp and provisional and for me to show patient what the veneer is going to look like. This is currently my preferred printer and the material of choice because it just works great. It looks awesome. It looks really good. Yeah, it looks really good. So I find that very impressive. With regard to the printer, So the thing is that the print time estimate is actually completely wrong on the unit right now, but actually it prints really fast.
Yeah.
So I'm surprised at how fast it prints, especially when you print it at 50 micron intervals. The tank system itself, the platform system itself is great. The platform is really, really beefy. You can try it out later. It's a real heavy piece of stainless steel. The entire system just feels very durable. Yeah, so I like that about the entire system. I really like the line. I like the big touchscreen. Also, it detects a peeling force and it shows you exactly that. And I want to say that the first week I got the printer, we're printing a denture base, and because we're so busy running around, I didn't check. So I made a rookie mistake of lefting the print on there. I started another print. So I don't advise anybody to do that, right? And then all of a sudden, I got this notification on the screen that I detected the error. I'm thinking, oh, I'm getting failure for the very first time on the HeyGears system, and then see what's going on. I left the print on there. The peel force sensor and the Z-axis pressure sensor on the unit detected that was a print on there. There was no damage on the tank whatsoever. Had this been other ecosystem or cheaper ecosystem that doesn't have that, you would wreck the printer. The printer will be done. There'll be resin all over the place. And if you have an LCD printer, the LCD will be cracked. You're done for the day. But basically, the printer saved itself. And it sounds like I tested on purpose in destructive testing. I didn't. It was a pure accident. But I was really surprised that it has that function, and it was really good. It was a lifesaver.
Yeah. So I mean, we've been talking about lots of things: printers, hardware, software, applications. One of the things that I'm looking forward to is, and this is I guess my specific special interest, is printed restorative resins. We don't really have a term for it, so that's basically what I'm calling it right now. I know HeyGears is coming out with their new Crown LT resin, which is supposed to be for more definitive use, long-term use. It does look very nice. It's easy to polish, and yeah, it's one of those materials that I think will become more and more mainstream in clinical dentistry as 3D printing becomes more, taken up more by dentists and practitioners and offices around the world. And I think one of the advantages of 3D printed restorations is the fact that, yeah, you can repair them, they're low cost to reproduce, very low cost. And it's very easy to reproduce as well. You don't need any firing cycle, you don't need a furnace to fire these restorations. They basically print, cure, polish, or characterize, and away you go. I think it's very cost efficient for many patients, because many patients will not be able to afford the traditional milled ceramics. So this is kind of like your next best option. And if they break, no biggie, If I can repair it, fantastic. If I can't, okay, I'll just reprint it and away I go. And and that's the beautiful thing about digital dentistry as a whole. The fact that you can have everything stored somewhere on a server, either physically or in a cloud. And if something breaks, if something needs replacement, then you can repeat the whole process. It's not the end of the world. It's such a wonderful time to be in. And I'm looking forward to when this resin is released, because I think it does have a place in the market. I think a lot of patients will be able to benefit from it.
I agree with you. I think in terms of the LT Crown, which stands for long term, currently for 3D printed restorations for inlay and for onlays, I feel pretty comfortable placing them as a permanent, because we've been a Cera user for so long, and usually we use Impress to actually mill or Vita to mill these inlay and onlays. And so often when the mill comes out, it's already cracked in half. Because the inherent nature of the milling technology. So what happened is that, in terms of the accuracy as well, we have never been able to get a really, really good fit on inlay and onlay. The occlusal anatomy is completely obliterated in CEREC technology. And reason is because even though they tell you they're down to 25 micron accuracy, the tooling set that's used to actually mill these things at the minimum is 1.2 millimeter wide. And for their larger drill burrs is 3 millimeter wide. So anything that's literally under 1.2 millimeter is completely obliterated. Whereas on a 3D printer, Even on this printer, the XY will be 75 microns. So you can print down to the pixel detail. You can have a groove that's 70 microns wide and it will reproduce that perfectly. Yeah. So I noticed that when we print properly on a material that's properly calibrated, we get much better anatomy than anything that we can mill. We don't have to go back there and hand finish it. Also, it's much less brittle. So for smaller restoration, you don't have to worry about the ceramic breaking in half when the patient bite down. They're a little bit more flexible. Now, they're not bendy, they're slightly more flexible. So in my experience, they have lasted longer than I have expected. There's some cases I'll always print over mill, and the reason is because I don't know if the tooth is gonna last. Do we just put a temporary on there, or do we 3D print a crown, charge a patient half the price, or 40% less? Let's see whether or not it lasts. And if it lasts, we can always replace that with permanent zirconia or EMAX restoration. But if it doesn't last, well, at least the patient didn't pay the full fee for this, because we're not sure whether or not this is gonna work. There's a lot of usage for this. We have some patients that really wanted to get veneers done. They can't afford the ceramic veneers. So now we have a different option. So, okay, you can't pay for this. Your budget is here. We can work with you. I don't have to mill this with hundreds of dollars out of pocket. I'll pass the saving out to you, but I always tell the patient, we don't know exactly how long this is gonna last. I'll warranty it for a period of a year, half, 2 years, but after that, we'll work something out. But I can't tell you that you will last as long as laboratory fabricated ceramic, not because I think it won't, because we don't have long enough clinical data. If that's okay with you, the bond strength is just as good, aesthetically it looks pretty. I think we need to work on the staining and glazing a little bit, but I'm comfortable using the material today. So this week alone, we have done about 5 cases of printed restorations. And I always tell the patient the same informed consent, and they're perfectly happy with it. I think the future is bright for that. Again, going back to the question, should we mill Chairside or should you print Chairside? No, the question is that, well, a Chairside mill is 200 grand. A Chairside printer system is about 10, 15 grand. That's a huge difference. Right, that's a huge difference. So I think we're gonna get into the new world of dentistry, where most offices are gonna have intraoral scanner. Most offices are gonna have a 3D printer, but still very few offices will have a chairside mill. Very few offices will have a full CBCT in the office. From a practical standpoint of view, I see the 3D printing field to continue to grow at a rapid pace, because honestly, in terms of what we can produce, and in terms of the expansion of the services that we can offer clinically, the ROI for 3D printing technology is incredible. And I can't say the same thing about CNC mill, to be honest. And I know on the CNC side, if you buy a CEREC machine for $200,000 and you charge $1,000 a crown, after 200 crowns it pays for itself. That's not how it works. The way that I calculate ROI is, hey, if I can do 5 more cases of orthodontic aligner because I have this in-house, I can charge a patient less. That 5 additional cases goes into pay for the printer itself. If I can do way more splints, because now I can do it at a lower cost and more efficiently, I can scan and design this right now. If I can promote more veneer cases, if I can offer cases like these partial dentures that otherwise the patient might have rejected, these are new services, these are new productivity that my office got precisely because of this technology, that I'll count towards that. In that aspect, there's no comparison. There's no comparison. A 3D printing ecosystem ROI is way superior to any chairside mill. Not only because it costs 1/10 as much, but because of all the new services that you can offer. Whereas, for better or for worse, chairside mill, really the only thing that it does is it allows you to save time.
And then you raise a good point as well. When we think about chairside milling, I'm not talking about lab milling, but chairside milling, most offices will just think, okay, crowns, inlays, right? Whereas with a printer, this is just technology to help you achieve and bring your imagination to fruition.
So it's been great talking to you today, Andrew. I know we chat online all the time. I see your posts all the time. I know you see all my nonsense posts all the time as well. I feel like we're similar type of people, just on 2 different coasts, 2 different ends of the Pacific Ocean. So I look forward to visiting you at Australia sometimes, but I really appreciate your time. It's such a pleasure to have you here in America with us, and it's an honor for me to have you in my office.
No, it's really been fantastic, actually, meeting face to face. After so long. But I mean, to conclude, I think 3D printing has a lot to offer in clinical dentistry. There are a lot of applications, and it's becoming way more predictable, way more reliable. Prints are becoming more consistent. So I don't think there's been a better time to get into 3D printing.
Yeah.
And yeah, looking forward to what companies like HeyGears come up with in the future, how they can help streamline the process even more, make it even easier, how they can really make 3D printing basically part of the furniture of a dental office.